the question, check if there is a valid partition of the array. So basically we are given an array and we need to partition it such that it has these three properties. So a subarray consists of exactly two equal elements. For example, a subarray is 2, 2. So if you are partitioning it into a size of 2, then both elements would be same. Now the second is if a subarray consists of exactly 3 equal elements. For example, the subarray 444 is a good. Yeah. So if you are partitioning it into a 3 size subarray, then that 3 elements would be equal. Or if it is one more check is if it is exactly 3 size, it can be strictly increasing by 1. So 3 4 5 is good, but 1 3 5 is not good. So if we have one array like this 4 4 4 5 6, we have to partition it into the size of, like, the subarray size should be either 2 or 3. So if we take 8, then what we can do is we can have 3 3 2 this size, or 3 2 3. So we have to divide the array into 2 3, I mean combination of 2 3 2 3, similar to that. But only check which we have to see is if you are divided into 2, then that 2 elements should be exactly same. If you are dividing it into 3, then that 3 elements should be same, or either is strictly increasing by 1. So if we take this example, which is 4 4 4 5 and 6, here can anyone tell me what can be the solution? One way is like we divide this 4 4 together and 4 5 6 together. Yeah. So Srinivas has given. Is there any other way? No, right? So this completely is a valid sequence. So we return true. Now if we take the other example, which is 1 1 1 and 2, is there any way like we can divide it into subarrays and we do not I mean we follow these conditions also. So if we take these 3 together, then 2 is left alone. This is a false condition. If we take 1 1 together, then 1 2 is left, which is I mean if we are taking 2 size subarray, then it should be same, else it is not possible. So this is not possible, so the answer is false. Right? Now how do we think like of such problem, like how to solve it? So let's see the constraint also first. If this is my constraint, num length is 10 power 5, can anyone tell me like what time complexity solutions can pass? Can n square pass? If we write a solution of n square, can it pass? No, right? Yeah, n log n can pass because 10 power 5. So 10 power 5 into log of 10 power 5, it will pass. Now let's come to the discussion. So we'll take the first example, which is 4 4 4 5 and 6. Yeah. So anyway, here it's given that the length of the array will never be less than 2. But just tell me, if we take only one number, that is 4, is it a valid array? No, right? Let's take 2 number. Is this valid together? Yes. So I'll write true. This is false. Let's take one more 4. Is it valid together? 4 4 4. Okay. Now if I add 5, is it valid? So how do you determine that this is not valid? I mean, manually, if this is a small array, it is easy to figure out that there is no combinations where we can fit all the required conditions, right? But one way, can you tell me if this would be a valid sequence, then uh, the last part would be either, when we divide this array, the last part will be of two numbers or either three numbers, like 5 will join either 4 or 5 will join 5 4 4, right? This is the only two conditions. Like if it is a valid pattern, then definitely 5 would join 4 or 5 would join 4 4, last three numbers. So we'll explore both conditions. Let's say 5 joins 4. Instead of 5, let's take another number such as 4. So if it is 4, this two is a valid division, right? So this is valid. We just need to see whether the previous, I mean, if till here it's n minus 2 is valid or not. If this part is also valid, this part is also valid, we can say completely it's a valid. Okay, another condition can be like, let's say we have this. So this last four can be combined with last three numbers. And if this is valid, we see this pattern which is left out is valid or not. So if this is valid, the before number, if we see both, if both are valid, we can say the complete sequence is valid. The meeting will stop now. I'll share another link in the